So, hello everyone. Today we are going to start a new chapter of physical geography, that is chapter 11, water in the atmosphere. So, let's start the topic. So, as you can see, as I have written in the book, that the percentage of volume of water in the water vapor in the atmosphere is around 0 to 4%, and it is less than 1% in the desert area, while 4% in the coastal area. And the reason is that the desert are the most driest place, while the coastal areas have ample amount of humidity because of its contact with the sea and oceans, because of which the humidity is rise. And this 4% and 1% is actually the at absolute humidity. As we proceed ahead, we will let to know about more about absolute humidity, relative humidity, and relative humidity. So, firstly, what is humidity? Humidity is the amount of molecules or moisture that is present in an atmosphere in a like it is actually the density of it. So there are two types of humidity. The first one is the absolute humidity, and the second one is relative humidity. The absolute humidity is the amount of water vapor present per unit mass of air, and is expressed in gram per cubic meter. It is in actual term. For example, if uh, there is 1 meter cube of air, in which uh, around 5 grams, or sorry, 2 grams of humidity is present, then 2 gram divided by 1 meter cube, that is 2. The absolute humidity is 2 gram per meter cube. The SI unit is gram per meter cube. That is more related to the density. Where the relative humidity is, it's actually a bit complex to understand first, but by the explanation I will get it cleared for you. The percentage of moisture present in the atmosphere as compared to its full capacity at a given temperature is known as relative humidity. So what is the what does this mean? This statement means that the amount of moisture that is present in air to its full capacity at a given temperature. So as we know that the humidity is directly proportional to the temperature. So as the temperature rises, the humidity, the water content, the water retention property of the air also increases. And therefore at for a there is a graph, let me show you here, of relative humidity and temperature graph. So so let's take this one. So here, amount of water in air at 100% relative humidity across range. So at 10 degrees Celsius, the air at 10 degrees Celsius, the atmosphere at 10 degrees Celsius can hold around this much amount of water. Okay, and this is so this is at the 100%. This is the total capacity that the water that air can have without condensation, before that. That is dew point. We will come to the dew point later. So this is the relative humidity, the percentage of moisture present in the atmosphere to its full capacity. How much it can absorb at a temperature is known as relative humidity. For example, if a air can have, that is 3 gram per meter cube of air at a 25 degrees Celsius, just taking an example, and if it has, and the actual humidity present in the air is 1.5 gram per meter cube, then relative humidity will be 1.5 divided by 3, that is amount present, humidity present right now, divided by humidity at its full capacity at that temperature. So this is the relative humidity, that is 2, sorry, that is 5, that is 50% in this. Okay, now moving to the next paragraph, that is the relative 80%. The relative humidity is 80% in coastal areas, while 20% in desert. Okay, so here we already know that 1% is for desert, the absolute humidity, 4% is coastal area, while the relative humidity in coastal area is 80% and the desert is 20%. Now moving ahead, So when the air containing moisture to its full capacity at a given temperature, it is said to be saturated. So as I have told you that the relative humidity, it is an it is related to the amount of moisture to its full capacity at a given temperature. So here what it states that if the relative humidity or the humidity have is increased or the temperature decreased such that the you after which a certain like it's impossible for the air to to get more moisture to it. This is said to be a saturated. It means that air at a given temperature is in capacity of holding any additional amount of moisture at that stage. The temperature at which saturation occurs in a given sample of air is called dew point. Where the saturation occur, where the relative humidity is 100%, it is the dew point. Dew. Okay, and means after that the water vapor will not be water vapor. It will turn into the water, turn into water. Okay. The amount of water vapor in the atmosphere is added or withdrawn due to evaporation and condensation, respectively. Yes, it's almost correct. Uh, Totally correct. Evaporation is a process by which water is transformed from liquid to gas. Heat is the main cause of evaporation. The temperature at which water starts to evaporating is referred to as the latent heat of evaporation. Okay, so as I have told earlier that increase in temperature, as the temperature increases, water absorption and retention capacity of the parcel of air also increases. Means temperature is directly proportional to absorption of water. And also like greater the movement of air, the greater is the evaporation, as we know. The transformation of water vapor into water is called condensation. So what are the factors for condensation of air? So condensation results from cooling around very small particles termed as hygroscopic condensation. The dust particles in the air which was moving, and then it gets contacted with one molecule of water, then another, and it develops into a water droplet. This is called condensation. Water droplet around that hygroscopic nuclei. The dust particle is known as hygroscopic nuclei, and the process is known as hygroscopic condensation. So particles, जैसे the smoke and salt from the oceans, are particularly good nuclei because they absorb water. Okay, when the moisture comes in contact with some colder objects, it may also take place. So there's a second condition is that if they comes in a colder surface, then it take place. So when we took a cold bottle from our fridge and put it over the shelf in a hot day, then we see that there are some water bubbles over the surface of the bottle. This is the condensation. uh, okay, so moving ahead, condensation therefore depends on the amount of cooling and the relative humidity of the air. Condensation, so these are the four parameters on which the condensation depends upon. The first one is the volume of air, the temperature, pressure, and humidity. So how they are related to. So as we increase the temperature, as we increase the temperature or decreases it, if it decreases it, then the condensation becomes faster, or condensation becomes easier because it reaches to the dew point more easily. The pressure, as we increase the pressure of a system, pressure of a system by, so its volume decreases, and if the temperature also decreases, then the moisture content, the moisture, that is the volume, decreases, because of which the amount of moisture percentage of absolute that decreases, the percentage of moisture increases. And as the temperature decreases with the decrease of increase of pressure and decrease of volume, it reaches to closer to the dew point, and condensation becomes easier. And the humidity, as more is the humidity, the closer it is to reach the dew point or the condensation phase. So condensation takes place when the temperature of the air is reduced to dew point. This is what I was talking about just now. with its volume remaining constant. When both the volume and temperature are reduced, these are the four factors when condensation takes place. The first is the temperature of the air is reduced to dew point with its volume remaining constant. The second is when both volume and temperature are reduced. The fourth one is when moisture is added to the air through evaporation. Okay, however, the favorable condition for condensation is a decrease in the air temperature. The most favorable condition because of which the condensation occurs in our atmosphere is because of the decrease in air temperature. Because volume of air is constant over the earth, the pressure is almost similar, that pressure required to for the condensation is like for the condensation increase and decrease, that is insignificant. The temperature change over the pressure change over the earth. And the humidity is mostly a geographical specific parameter, which is almost constant for a certain area for a higher amount of time. So what are the types of condensation? So after condensation, the water vapors or the moisture in the atmosphere takes place one of the following forms. Like these are the forms of condensations. After the condensation, the water vapor takes these are the forms. Not this is not the condensation. These are the forms taken by the water vapor after the condensation. The first one is dew, frost, fog, and cloud. So let's see one by one. The first one is dew. So what is a dew? Dew, as we know, as we have studied earlier, somewhere before, that dew is when the moisture is deposited in the form of water droplets on a cooler surface. Just I have given example of a water bottle taken out of a freezer. So there the water got condensed, and this is called dew. But in our atmosphere, when we go out in the morning, we see that there are water droplets over the grasses and also over the trees. So there the dew is naturally occurs. So what are the ideal conditions for the dew? The first one is the clear sky, the second one is calm air, the third one is high relative humidity, and the fourth is long and cold and long nights. So mostly we see dew in February, March, and initial April, and also in October, November, December, January. So these are the conditions and the time period when the dew occurs. So what is it? So there is another term that what is frost. So the one major difference between dew and frost is that dew occurs when the atmospheric temperature or the surrounding temperature is greater than the freezing point, that is 0 degrees Celsius. But for frost, the condition is that it occurs when the air temperature is less than 0 degrees Celsius, because of which the water droplets freezed over the surface and forms minute crystal. The ideal condition for the formation of white frost are the same as those for the formation of dew, except that the air temperature must be at or below the freezing point. Okay, so fog and mist. So fog and mist. When there is a certain decrease in temperature of large quantity of water vapors, then condensation takes place around the dust particles. So these are the surface phenomena. Dew and frost are the surface phenomena, while fog and mist are the atmospheric phenomena. It occurs in the open space, not over a surface. So what is required in this? A hygroscopic nuclei is required in fog and mist, while dew and frost, a hygroscopic is not required, just a surface is required. So when the temperature of air mass containing a large quantity of water vapor falls all of a sudden, condensation takes place within the itself of a fine dust particle. So this is about the hygroscopic nuclei that we are talking about. So fog is a cloud with its base at or near the ground. Because fog and mist, the visibility becomes zero. So we can relate it to our winter days, that the temperature suddenly decreases and the atmosphere has ample amount of humidity, because of which it turns into fog and mist. In urban and industrial area, as we know, there are carbon dioxide, nitrous oxide, sulfur oxides, and other gases are involved, because of which the it have plenty of nuclei, and it creates a smog condition. What is the difference between a fog and mist? So where I zoom here, so fog is thicker while mist is less denser. Fog has lower moisture content while mist has higher moisture content. Fog is much drier because it has lower moisture content, and mist is much wetter. Fog is frequently over the mountains as the rising warm air up the slope meets the colder surface, while mist forms when the warm current of air mass is mixed with cold current. So fog occurs over the mountains because of the rising, but mist is actually a phenomena because of uh, a front phenomena. Mist forms over the fronts, cold and warm air, while fogs is a phenomena which is formed by rising warm air. So mists are frequent over the mountains as the rising warm air. Fogs are drier than mist, and they are prevalent with warm currents or air. I think that there is some mistake here that I have written. I have to exchange this. Okay. So, and yeah, one more thing, that the visibility of fog is lesser than the mist. Okay. Now coming to clouds. So what does so as we know the clouds. So according to so these the clouds are have been distinguished to their heights, how much their size are, how much dense they are, and how much their transparency and opaqueness. And on the basis of this, there are four types based on the heights and the appearance and the size of cloud. Four types are have been initially being categorized. The first one is the cirrus, cumulus, stratus, and nimbus. So, what is cirrus? So, clouds are the highest cloud. They are feathery in nature. These are the highest clouds and exist more than 8,000 to 12,000 kilometers. For an estimation, for just the planes, the flights that we used to travel, the normal airlines, it used to travel around 10 to 12 kilometers above the sea level. So, these are the clouds that we used to see when our plane used to get over get over the clouds. So so they are thin and detached clouds having feathery appearance, and they are always in white in color, and they are solid, made up of ice, and it appears on the nice weather. For example, let me show you. So these are the examples of cirrus clouds. So as you can see that these are feathery in appearance, white in color, and they are solid, and they exist 8,000 to 12,000 kilometer of height, the highest cloud. And also these appears, as you can see, this type of weather is really beautiful and really mesmerizing. So this is these are the cirrus cloud, white, solid, and you can see here why I have summarized the whole paragraph in these points. Now, what are the cumulus clouds? So cumulus are the cotton wool. They have a flat surface and nice weather. So let me cumulus clouds. Cumulus clouds, flat base, 4,000 to 7,000 kilometer, and exist. They can be scattered here and there and have a flat base. So these are the cumulus cloud and these also appears on a good day, in mostly in the times of monsoon, these or when the monsoon breaks, these clouds appears. Now coming to stratus clouds. So these are the lowest cloud, exist around 2 kilometers from the MSL, and they are mostly in gray color. It covers a larger portion of the sky. And strata, so it is derived from that it is uh, constantly been that it is constant over the sky. So these are the stratus cloud. So as you can see, this is formed because of the frontal systems, and these are the indications that the storms or the rains are coming too soon, that they are coming soon. So it is low, gray, and covers large portion of the sky. Sheets in sky, as I say, strata, formed by mixing of air masses with different temperature. It means soon rain will occur. So this is the stratus cloud. Coming to nimbus. So nimbus are the clouds higher than stratus, but nimbus is a property of every cloud. It's not a single cloud. For example, nimbus are black and dark gray color, and these are opaque to sun rays. Let me show you nimbus clouds. So these are the nimbus clouds. These are gray color, and these are indication that the storm is, like, either we are in storm or the storm are going to come. Thunder and lightning, these have not any specific shape. Okay, so this is about the clouds. And there's a one thing, I've taken this from GC Leon, that the amount of clouds cover in the sky expressed in 8 or octas. Let me show you octas clouds. Okay, so these are sky is completely clear. These are the 8 octas. 9 grams sky obstructed from view. No, this is not any octa. This is something unrelated to it. Sky obstructed from view, either you're in jungle or in a building. So sorry. Okay, so octas 0, completely clear, 1 2 3 4 5 6 7 8. Just for and value addition. Mostly it will not be asked in UPSC, any of the UPSC exam. So these are the properties that we have already discussed about nimbus, that they are shapeless and dense and opaque to sun rays, and they sometimes are so low that they touch the ground. Now, there are two types of okay, so moving ahead, firstly, uh, talk about the cloud burst. So what are cloud burst? So sudden heavy rains in a small amount of area, with like high thunder and cloud, and the rain is around 25 to 30 centimeter in couple of hours or minutes. So this cause a sudden heavy barrage of water coming, because of which process is called the cloud burst, and it occurs mostly during the daytimes and in the hilly areas. Mostly in hilly areas. It is possible also in the plain areas too. So moving ahead, so what are the combination of these four basics? So there, the clouds are not always present in this SNCC, that is stratus, nimbus, cumulus, and cirrus forms, but it is mostly, it exists in a combined form. So the high clouds that are cirrus, stratus, and cumulus, these are the high clouds. The cirrus are the high clouds, as we know that they exist 8,000 to 12,000 kilometer. So cirrus, so if we see this cirrus, then we are sure that these are the high clouds. Then alto, stratus, and cumulus. So alto, stratus, and alto, cumulus, these are the middle clouds, stratus and cumulus. The low clouds are stratocumulus and nimbostratus. Stratus are the low clouds. So if stratus comes in front, then these are the lower clouds, and alto if comes, then it is middle clouds, and cirrus comes, then it is higher clouds. So, and the clouds with higher vertical development are cumulus and cumulonimbus. Cumulonimbus are the vertical and the longest clouds at present, and it is spread to thousands of meters. And these are the clouds which are responsible to stormy weathers. There's a one more term, mackerel sky. Mackerel sky. This question has been asked by UPSC several times. So mackerel sky are the formed by the cirrocumulus clouds, and these, like, more, it was mostly visible in the monsoons in the evening time, and it has a rippling effect. Rippling effect, matlab, it is it has been arranged in the atmosphere, not arranged, it has been in the atmosphere uh, constantly, but there are some spaces between the clouds, a certain distance, a constant, around constant distance. So this is the rippling effect entirely made of ice, because it is cirrus clouds, cirrocumulus. Cirrus has been ended before that, so it is high, entirely made up of ice and high altitude. It is found in high altitude. Let me show you MACKERL, mackerel sky. Okay, so this is the mackerel sky, and it really makes the sky beautiful, and is mostly being seen in the uh, monsoon evening, and also before or after monsoon days. Now, what is precipitation? So precipitation, the process of condensation of air because of the decrease in the temperature. As we know that the warm air rises up, and the warm air absorbs high amount of humidity from the atmosphere. When it rises up, it cools down very quickly because of that higher temperature gradient, higher vertical temperature gradient. And in this process, because of the decreasing temperature, the water condenses, and the condensation process of the water causes the precipitations. So the precipitation in the form of water is called rainfall. When the temperature is lower than 0 degree, it will be called as snowfall. Okay. uh, okay, moving. So snowfall is formed by when the water cools between at or below 0 degree Celsius. It forms snowflakes. While this is sleet are the frozen raindrops. As during the monsoon or in the initial April, we we used to see water sleets, the uh, what frozen water falling from the sky. This is called sleet. And the third one is the hailstorm. When the sleets grew in higher sizes, crops the size of a golf ball, then this is called hailstorm. So this sleet and hailstorm can be found at the tropics, while snowfalls are always possible in the either in the high altitudes or in the polar regions. This is complete. So sleet is frozen raindrop, and refrozen melted snow water. Sometimes raindrops, after being released by the clouds, become solidified into small rounded solid piece of ice which reaches the surface, called hailstones. Okay, so types of rainfalls. So what are the types of rainfalls? There are three types of rainfalls. First being the conventional rainfalls, orographic, and cyclonic or frontal rainfalls. So first one is conventional rainfall. So first giving an example and then going back to the definition. Convection rainfalls occurs on the coastal areas or in the equatorial regions during the summer, during after the afternoon or in the evening time. So how does conventional rainfall occurs? So the the air on being heated becomes light and rises up in convention currents. So it rises up as it expands and loses heat. Consequently, condensation takes place and cumulus clouds are formed. With thunder and lightning, heavy rains take place, but this does not last so long. Such rain is more common in summer or in the hotter part of the day. It is very common in the equatorial and the interior part of the continent, particularly in the northern hemisphere. This is common in the northern hemisphere. So on in the coastal areas or this thing is much common in the summer. Okay, so what is the orographic? So as we know, when the air rises up, it gets cooled down, and also it expands because of decreasing pressure. And when the pressure decreases and also the temperature decreases, it forms clouds. It forms precipitation. Sorry, for not clouds, but it precipitates. The water will condense and then it precipitates, and this type of rainfall is called orographic rainfall. So this is the image of a mountain. This is a mountain, these are tree. So when wind moves upward, they cools down and then rain occurs here, and when they falls again, they left their moisture here, and when they moves here, then they becomes hot, and the hot air can take much humidity. Because of this area, they used to take up the humidity from this region, and because of this, this area becomes much drier. So this is called leeward side or windward side, and this one is called the rain shadow side. This have more vegetations over it, and this have lesser vegetations. So this is also a reason that Himalayas on the southern side of Himalayas, that is Indian side, have much more vegetation, while on the other side it has lower vegetations. This is one of the reasons. Uh, so and so there's an one task for you, where just search some of the mountains or mountains or the regions, plateaus, where this phenomenon is more common, that one side is this full of vegetation and there is not. So you can study, you can read whatever is written here. I have explained it to you. And the cyclonic rain, as we know that the cyclones, so there are two type of cyclones we know, cyclone and anticyclone. Because of this, the rain occurs in India. It mostly occurs during in a time period of April, May, June, July, August, April to October mostly. The cyclone occurs, and because of the changing weather patterns, the cyclone are becoming more common. So okay, so before uh, ending the types of rainfall, so there are two questions that the UPSC have asked. The first is, what is collision coalescence process, and the second one is this Burgeon's process of precipitation. So there's not much, so don't think much because by the name. The simple is that collision coalescence process, it occurs in the tropic and subtropic regions, and this Burgeon's process of precipitation, it occurs in temperate on the polar region. So if it occurs in tropics and subtropics, then definitely water is involved, and if this occurs, then there is definitely snow is involved. Okay, frozen ice is involved. And the collision coalescence process, large water droplets force down. When the vapor goes up, they used to condense and form large water vapors. They used to force down to get, because of the gravity, simple. And in a way, they get attached to more small waters. When they are falling, they used to get small waters and become bigger. But after, when they gets down, because of the air friction, they gets dissociated, they gets divided into smaller and smaller raindrops. So this is coalescent rains process. And the Burgeon's process is that in cumulonimbus cloud, which are very large in number, as we know, cumulus nimbus, as we have already studied here, that with extensive vertical development. So here, when the annual temperature or the temperature of the clouds, that reaches below freezing, the ice crystals are formed up in the clouds, and ice crystals are forced to down. And because of the air frictions and the increase of temperature of around the earth, they used to melt and the rainfall occurs. This type of process is called Burgeon process. So the difference between the collision coalescence process and the Burgeon's process is only about what happens in the upper layer of the sky. Either they are formed from by adjoining of the water molecules, or they are found by adjoining of, or by they are found by the ice crystals. This is the only difference that UPSC used to ask. So let me see if nothing is left. Okay, so world distribution of rainfall. As we proceed from the equator towards the pole, the rainfall goes on decreasing. This is because the heat distribution of air of the atmosphere is lesser over the poles and the higher over the equators. Because of this, the water gets more heated up around the equator, not over the poles, and it is directly proportional to the distribution of rainfall. Coastal areas of the world receives greater amount of rainfalls than the interior of the continent, because coastals are more reachable to the coastal areas, the sea, and the conventional form of rain precipitation occurs there more frequently. In the summer days, almost every day rain occurs after the afternoon or in the evening. The rainfall is more over the oceans than on the landmass. It's totally correct that the rainfall is more over the ocean. The rainfall is more over the oceans than on the landmass of the world. This is a point to be noted. Between 35 degree to 40 degree north and south of the equator, the rain is heavier on the eastern coast and goes on decreasing towards the west. So let's open Google Maps right now. So from this is equator. Equator passes from here, and this is the Tropic of Cancer, and this is 35 and 40. So 23, 35 and 40 may wear something here and here. So this is the strip of earth where the rain is heavier on the eastern coast because of the easterlies. Because of the easterlies winds are flowing between 30 degree to 60 degree, and because of this the rain is from over the eastern coast, as you see, like the area. As you see, this 34 and 50 degree, it is the land area here is more vegetative. It's more greener on the eastern side, while on the western side these are not that much greener, as you can see here. This Australian North American continent also, and on this region 35 to 40 here also. Okay, but 45 to 65 degree north and south of the equator, due to westerlies, the rainfall is first received on the western margin, and over here you can see that these areas are much greener because of the westerlies. These are more reachable to the humid air, or the humid clouds having higher humidity. The rainfall first received in Western Margin decreased towards the east. So these are the 2 points: 35 to 40 degree north and south of the equator. Rain is heavier on eastern, while on the 45 to 65 rain is more over the western margin. The reason is the easterlies and the westerlies. Okay, the equatorial belt on the windward of the mountain along the western coast is cool temperature and cushion. So on the equatorial belt, the windward slopes of the mountains, for example, this area, the Western Ghat. So these receive more than 200 centimeters of annual rainfall, while the interior continents, that is these areas of India, of our country, these areas 100 to 200 centimeter of rain. The coastal areas contain receive moderate amount of rainfall. The central part tropical, and the eastern and the interior part of the temperate lands receive rainfall varying 50 to 100 centimeters. So as we are going away from the coast and away from the equator, the rainfall pattern are decreasing. The rainfall intensity is decreasing. Area lying in the rain shadow zone of the interior of the continents and high latitude receives very low rainfall, less than 50 centimeter per annum. Seasonal distribution of rainfall provides an important aspect to judge effectiveness, and in some region rainfall is distributed evenly throughout the year, such as the equatorial belt. Around the equatorial belt and the western parts of the cool temperature region. So around the equatorial belt, the rainfall is constant. The rainfall is constant over the area. So you can see that these are the areas where there is greenery throughout the year. So these are the areas. So here, as it is written, that the regional rainfall is distributed evenly throughout the year, as in the equatorial belt. So whole the year the rain occurs. Now distribution iso heights. Okay, so there are some terms related to iso heights are the lines joining the places of equal rainfall. And one more thing is that India has like the monsoons in India are because of the seasonal reversal of winds. Indian monsoon type climate is found in northern Australia. China has Argentina type climate. So our Indian type monsoon type climate is found in northern Australia. So whatever type of climate that India has, it is found in the northern Australia, and Argentina has the China has the Argentina type climate. So these are the questions that has been asked in the UPSC. So I have listed it out, and so this is the complete understanding of physical geography, chapter 11, water in the atmosphere. So thanks for being here. Have a good day.